For your, well, on your phone. Your phone can do most of it.
Yeah, there's apps.
Not even that, but your basic calculator on your phone can do a lot of stuff.
Yeah,
Technically,
it's
since
probably better than
I
the
did this already, it's SRT, I think I should just take it. You literally said you were waiting to class to figure out. No, I already.
I definitely just.
Okay, this is base E and natural logs specifically, but we will have other logarithms in here as well. And honestly, it's just really a bunch of examples. Yep. So the first set of examples are just asking us to solve the equation.
Would we like separate steps in this, or just doing like all at the same time?
Kind of all the same time. Kind of fun. Okay, so the first equation we're looking at is 4 to the x equals 9. 19, not 9. 19. There are a couple different ways that we could transform this in order to solve it, but what's going to be the easiest way? Every exponential function can be rewritten as a log. So that means I can rewrite this as log base 4 of 19 equals x, right? We've done this. So now all I have to do is I have to solve log base 4 of 19. Did I introduce the change of base formula yet? This is where we do it. So our calculators do not work, or majority of calculators do not work in bases that are not 10. So there is a way around this. Majority of us cannot plug this in as is to our calculator. So the way we plug it in is we do log of the larger number divided by log of our base. Because this is equal to that, so that's what my x is going to be equal to, and then I just plug it into my calculator. This is called your change of base formula. Yeah, I would definitely do the top divided by the bottom, but it should still work out. We get what? No.
Oh, you have to do log. My brain can't do log.
Yes, 19 divided by 4 would be 4 3/4 stuff.
2.2.
2.1239. We are going to go to 4 decimal places.
I never.
We're going to leave it then.
Wait, so what? Okay. Oh, you don't put it like a 4.
No, technically you would if it rounds up that.
Okay.
So that would be that.
Thank you.
You're welcome. When in doubt, I do prefer 4 decimal places for stuff like this.
Would it make you feel better if I put a 0?
If you want to. The 0 after is just
What?
redundant.
Can we just like leave it like that? X equals put something around?
Nope, that is it. You can just do x equals that. How hard was that?
Was that always?
Kind of. That's the base of what we're doing.
So we have to add on.
It is easy.
No, it's not. It's hard.
So let's practice it again. This time, I have 6 to the x power equals 40. It's going to be the same process. So what am I first going to transform this into? A log is going to be log base 6 of 40 equals x. And then I'm going to solve for x by transforming the left side using my change of base formula. So x is going to equal log of 40 over log of the base 6. What do we get, kids? 2.0588. Show of hands who got that. Is anybody confused by what we are doing? Do we feel okay? Rowan, honey, what happened? Did you just not have a calculator, or? I won't throw it at you because I'd probably end up hitting somebody else in the face, and I won't do that to them.
What the heck?
Yeah.
Thank you.
Purple. Okay. Is anybody confused by this process? So let's make it a little bit more interesting.
See,
send you the same exact problem.
That would be cool.
No, it wouldn't. Oh, cruel, yes.
I said cool.
Yeah.
I think that is cool.
2 to the a plus 2 power equals 9. We're gonna solve this the same way we did before. We're just gonna have an extra step. So what's the first thing I'm gonna do since my variable's in the exponent? What's the first thing I'm going to do to solve this? How about I just change it into a logarithmic equation first?
Yes.
Why do I change it into a logarithmic equation? Or it brings my exponent down to the main level of the problem, which is really the only way that I can isolate it. That's the whole reason that we do this. So if I change this into a logarithmic equation, it will be log base 2 of 9 equals a plus 2. To solve this, I need to get a by itself. So what do I need to do? Subtract the 2, and it becomes log base 2 of 9 minus 2 equals a. So then to solve it, I will do it kind of in 2 steps. I'll do my change of base here, get an answer, and then subtract 2 from it to get my a value. So then this becomes log 9 over log 2 minus 2 equals my a value.
Why can't you just subtract 2 from
From what? Like at the very beginning?
I try
Yeah.
to type in the one.
I would definitely do this in 2 steps if I were you. I would do this part first, get an answer, and then subtract 2 from it. But it's up to you. What did we get? 1.1699.
Yes.
Let's just take a second to make sure we can all get that answer. They do not. I'm not going to expect you to use this with bracket.
So I'm pretty sure I still got that problem wrong after you told me how to do it.
That's okay. You get extra practice today too.
I don't wanna.
It's got 3 examples of lost out of.
Yeah.
We have one more example, and then we'll do a new set.
Answer that one. I'm sorry. I was thinking from one space.
Show of hands. Did anybody not get 1.1699? Does anybody not understand how we got 1.1699? Miranda, you okay? Did you get it?
Yeah, I got C.
Okay.
Oh, wow. Here.
Are there any questions so far? We're gonna do one more of these and then move into another set of examples.
I like these.
You like these? Okay, let's do another one.
Yeah.
I'm glad we did another one.
You. Trying to trick us.
Maybe, maybe not. You never know. Who has an idea of what we should do first? Change it into a logarithmic equation, yes. I'm going to do it using this side as my base. So 11 here is going to be the base of my logarithm. Technically, you could do it using 5 as your base as well, because both sides have an exponent of b. But I'm going to do it using the 11 on the left as my base. So this changes into log base 11 of 5b equals b minus 3. That's what that changed into. Anybody have an idea of what I can do to kind of simplify this a little bit more? Bolt, you have a question? You have an idea?
Kind of, maybe, did you square?
I can't square root of b because b is some unknown number. That would help if I knew what b was. Is there another way I can move that b from the exponent down out front, Madison? we have a logarithmic property that tells me that any exponent can be rewritten as a scalar multiplied into the front of my logarithm. In other words, it drops up front. So then this becomes b times log base 11 of 5 equals b minus 3. So now I'm running into the issue that I have 2 variable b's in this problem. 2 of them. I can only solve it if I get down to 1 of them. So I need to find a way to kind of get my b's in the same place. To start with, we're going to get all the b terms on the left-hand side of the equal sign and all the non-b terms over to the right-hand side. The good news is I only have to move one thing here. I'm just going to subtract this b over. So when I do that, I get b times log base 11 of 5 minus b equals negative 3. I'm going to put this in parentheses so the minus b does not get confused as part of the 5. I've moved the b to get all my b's on the same side of the equal sign. Because I need to find a way to turn 2 b's into 1. Does anybody have an idea of how I can do that from here? I can't multiply them because there's an operation of subtraction between them, so I can't just change that. Could I factor a b out of that left-hand side?
Sure.
They have a common factor of b, right? They both have a b in them. So in theory, I could just factor it out and put it out front. So if I were to do that, I would have b times log base 11 of 5 minus 1 equals negative 3. Right? So I just divided b out of both of these and put it out front. Or undistributed it. Everyone kind of okay with that? So that's how we take more than one variable that's identical and turn it into 1. Because that's the only way that I can isolate it and solve for it. So now it's going to be really easy to get b by itself, isn't it? What do I do? Divide by what, Keaton? How about I divide by everything except b? That's the only way I can get b by itself. So now I'm going to divide each side by log base 11 of 5 minus 1. And that's going to give me b equal to negative 3 divided by log base 11 of 5 minus 1. It's going to take us a couple steps to actually get the answer for this one. But we are going to work through it because that's what we do.
I wish you had given.
Oh, just kidding.
Oh, I did.
I was listening.
You're okay. So I really do actually need to solve this. So the first thing I need to do is change my log 11 5 into a change of base formula and make it log 5 over log 11. So this becomes negative 3 over log 5 over log 11 minus 1. And then I can put it into my calculator. Just be very careful with your parentheses. So the top should be in parentheses. And then it should go in just like that. Actually, I would probably do it like that individually, but same concept. You don't necessarily have to have those last 4 that I put in. It should work without them. So if you put it in just like that, it should work. I don't have an answer. I'm curious to see what we get. Yes.
Why in the beginning, when you had 5 minus 1 together, why wouldn't you just make that like a 4? Or is that attached? to the
Because
log?
they were, the 5 was attached to the log, but the minus 1 was not, which is why I put parentheses around it, so that we wouldn't
Oh.
get confused. So this should, that was itself.
Okay.
Yeah, I could subtract the 1 from that. A good question though, because that's a common mistake that I can see happen.
Is it a negative?
No, it should be have 9 as the whole number,
Oh,
and then it's gonna have decimals. Should be 9.1238.
Hey, that's so good. I did it.
Can I see how you plugged it in?
I put parentheses negative 3 divided by parentheses, log divided by 5. That had parentheses around it. And then put log 11.
Okay.
Parentheses.
You might not have posted out parentheses. Okay.
I
I don't know if I can. So plug it in again and then I'll look at it. But it should be 9.1238. It's never a bad idea to do this in steps. So calculators retain memory from the previous step. So you definitely could have done this part first and then subtracted 1 and then did -3 divided by your answer. You could have done it that way as well.
Yeah, I got 0.
I got -5.17.
Divided by
Okay, can you plug it in again and before you press enter, can I look at it?
Yeah, look at it right now.
That's why you didn't close your parentheses after 5. So log 5 divided by log 11, and we're gonna need another one there as well.
I'm still getting the same.
And now we're just,
Okay, thanks.
you're welcome. So I closed the parentheses after the 5, Sam, and closed it after the 11. Again.
Okay.
That's the only thing I changed.
When you close the log, I do. You have to close it. I do.
Make sure you have the appropriate number of parentheses for each grouping as well. Show of hands who's still not getting it, so I can keep track. Okay. If you did get it, turn to somebody sitting next to you who didn't and go through it with them. Brandon, middle years. Are you doing end steps or?
Yeah. I'm trying to do a lot 5.
I didn't do VA, but I just did. How I got. I do it separately. Yeah, I did do it separately. I probably don't.
Yeah, so
I
the log
do-
5, log 11 is 5.
And I'm going to
And you go all the way up to 30.
that is my one, and I write it down. Yeah, it's the process, but I need to do that answer.
You get a -0.032.
Yeah.
Because you
Today's
didn't
your last
do
day.
it, divided by that number next. So you did the entire denominator.
Yeah, but we weren't here Monday.
I thought I was getting
No, it's perfectly fine. So, go back to where you are.
I have the urge to.
And so try 1, get your answer, and then do -3 divided by your
So
answer.
it says, I don't know, I just heard like. Again,
Lila, honey, how you doing?
it sounds muffled.
Not good? Okay, I'm coming.
Like.
David, I'm gonna step over you. I'm so sorry.
It sounds beautiful. Yeah, don't be mean to our force. To make sure I didn't do that wrong.
Oh, wait. Oh, that was.
It wasn't a joke. You know what I think? I think it was. Okay. What problem was it? 2-6. I don't say. Yeah, like, I'm wrong. Look, it would probably help if I actually used the right number here. Everything is fine. That would be good. You're welcome.
Anybody else not get it?
Still got -5.2.
You have to close all the parentheses and Anybody else not get it?
I said that. I don't know what to do. We just chopped it in half.
Yeah.
It's like.
Ah, that'd be nice.
Oh my God.
Did you just the one Patty? I saw Patty on my wrist. That's scary. I don't want to. No, I did it one time. I did it right this time. I did. What if it's in there?
How did you know? Oh, really? It was .4 something.
Like, no, I'm talking about your part. Oh, I couldn't read it. Which Okay, so
Okay, I was watching.
I'm trying. Did you get 9.1 for senior? I'm one senior.
I was up there taking the seniors' time. The seniors were gonna yell at me. So I was trying to watch the
Okay.
The seniors loved to yell.
Did everybody for the most part get it figured out except for Brandon, but I'll work with him. Okay, does it make sense? So you just need to be very careful with your parentheses. That's the number one mistake I see. So I always suggest doing it in smaller quantities until you get really comfortable with how things get plugged into a calculator. But that just comes with the process. Are we all okay? That I think was the hardest it gets, to be completely honest, yeah. So now let's go ahead and do another set of examples. On these, we're going to condense and simplify. There are only 2 of these, so that should make it real fun.
Okay, so is that all?
That was all the notes for that particular part of this.
Yeah, but we only have 2 for the rest of them.
No, so there's one more set after this one, but in total, we have 8 examples left, including this one.
How many is 3?
Yeah, we'll leave that. So this one is 3 natural log of 10 minus natural log of 8. Yes. I said condense, which means that we are most likely using our logarithmic properties. I did tell you when we did them that they also apply to natural log. So the first thing I notice is what here that I can change. The 3 in front, where does that condense to? An exponent on the 10. So this becomes the natural log of 10 cubed minus the natural log of 8.
Why they choose like natural log? Like that's such
I honestly have no idea. Miranda, do you have a question? Somebody said something. No, you're okay.
I was asked a question, what it was like to myself.
Oh, okay. What am I going to do next to condense this?
Get rid of the one.
Subtraction changes to what? Division. So this becomes the natural log of 10 cubed over 8. And then, of course, I'm going to simplify it. So 10 cubed is, I'll slow down, 1,000.
Nope.
Divided by 8 gives me the natural log of 125. So all I did was simplify the values inside of the natural log. That was it for that one, because I just said to condense, I didn't say to solve. However, if I said to solve, we have a natural log button on our calculator that we would just plug that into. It is underneath log and above pi, if you have one of my scientific ones. If not, sometimes it's with the
So
E,
it'd be 4.828.
if we were to solve it, but we're not. Is everyone okay with how we condense this? What's your own? Your spacing, okay. Is anybody confused by how we condense it? So we're gonna do one more just to practice and then move on into the next section. So example B.
I know, but they're pretty. At least my name.
If you feel comfortable, you're more than welcome to work through this on your own. However, I will go through it a little bit slower in case anybody is confused. So the first thing I notice on this one, because I'm condensing, I'm gonna say converging all the time. Because I'm condensing, is any number in front of my natural log becomes an exponent on the value inside of my natural log. So I just have one of them. This 2 is going to become an exponent on the 1/2. So then this becomes natural log of 40 plus natural log of 1/2 squared plus natural log of x. Then I recognize that the addition of 2 logs becomes multiplication. I actually have 3 and they're all being added, so it's all going to turn into multiplication. So then this becomes the natural log of 40 times 1/2 squared times x. And then from here, we're just going to simplify inside of natural log. So 1/2 squared becomes 1/4. So I have 40 times 1/4 times x. And 40 times 1/4 becomes 10 times x is 10x. So that simplifies into the natural log of 10x, which is much easier to work with than the what we originally started with.
Will we ever have to go back?
From here, it's almost impossible to get to that because we don't know what we originally had. So you could definitely go from here and kind of find an option of what it could have originally been, but it's almost impossible. Given if you didn't have any initial conditions, you really couldn't. Questions, concerns, or issues on this one? No, we're okay? Awesome, we still got 20 minutes.
We should go outside sometime.
This is our last step. I actually love teaching outside.
Oh. You know, I'm trying to figure out what you're doing.
Did we ever do that one time?
What?
Go outside.
Yeah. I'm fine with that.
Probably really good shirt.
Gene,
Ew.
It's all,
Oh, I think
no, I see nothing wrong with some fresh air one day.
It's like 45 outside.
I know.
it's not real. It's bad. It's there for the butt.
I think this is.
Oh,
you're gonna.
No, the last week was literally. That was just.
Okay, so the equation that we are trying to solve is 4e to the negative 2x, all minus 5 equals 3.
Oh.
My goal is to solve for x, so I'm gonna have to move everything else first. What do you think is the first thing I'm gonna move here? The negative 5. I'm definitely gonna have to add that over to the other side. I don't know if you guys realize this, but whenever we're solving for an equation or for a variable, we do order of operations backwards. So we always start with addition, subtraction. Then we move into multiplication and division, and then we go into exponents and parentheses. So it's always order of operations backwards when we're solving or isolating. Wow. Yeah, that would work. So make sure you just have that somewhere in your brain. If you need to write it down, you absolutely can. And it's very, very helpful. So we always start with any addition or subtraction that's happening. Here we have the minus 5. We do the opposite, so we add 5 over, and we get 4e to the negative 2x equals 8. There's no other addition or subtraction, so now I move to multiplication or division. Divide the 4, yep. When I do that, I get e to the negative 2x equals 2 because 8 divided by 4 is 2. Are we all okay with that? So now I have the issue that I have a variable in my exponent and it has a base of e. Anybody have an idea of what we can do with this? So one option is we can change this into a logarithmic equation. But as Jalen already pointed out, we've already discussed what naturally cancels out an e. And it's natural log. So the shortcut to doing this, so it doesn't require you transforming this into a logarithmic equation, although it works out the same way that way as well, is that to cancel out this base e, I take the natural log of both sides of my equal sign. When I do that, the natural log and the e cancel, letting my exponent come down. And then I'm left with negative 2x equals the natural log of 2. And then it's really easy to solve from there. So anytime you have an e, We take the natural log of that side and the other side, and it will cancel out that base and let the exponent drop down. So now to finish isolating the x, what am I going to do? Divide by -2, and I get x equals the natural log of 2, all divided by the -2, and we can put that into our calculator. What's wrong?
I thought it canceled on both sides.
No, it only cancels if we have a base e. There was no base e here, so that one has to stay.
I think I
Can
got
you say that again, Brandon?
-0.3465.
I had 6.6, but
It is 6.
is it okay?
Yeah.
Someone can't.
But if you said 6.5, it's okay. I would definitely count that because you were close enough.
We can't even do math.
If we, like, let it be like round.
Small victories.
Small victories. Like the.
Make it
Like that one was one.
And that's not that big of a deal, just need to round it somewhere else.
Okay, so if like I put something, if I put that down on like.
If it was in the tens or the hundred place, I would probably, but not in the third or fourth. That's fine. That's okay. No, that's okay. That's how you want to do it. Go for it. If you want to, that's okay. Okay, we are getting very, very close to being done. Did anybody not get this to work out to -0.3466? Do we understand how that happened? Okay, we're gonna do another one because I think it's a really good practice, and then we'll move into a couple more fun ones.
That's not.
Well, we have 4 more examples.
She did the smile.
Come on, let's do
She did the smile.
and then we can do our.
I'm waiting for the mystery H to show up on here.
Your homework is 5 problems, and it's very straightforward.
I feel like we try to involve something we haven't.
Oh no, everything that we're doing, we've gone over.
I don't believe it.
If you feel comfortable, you're more than welcome to work through this on your own, but I will take this at a slower pace for anybody who maybe is still kind of grappling with it. So the first thing I notice is that I add the 12 over,
I did not just put that to the calculator.
then I divide by 3, and hopefully in our brains we know that's 9.
Did you really just put that? No, I put 12 plus 15.
I have to somehow bring my variable down to the same level as the rest of my problem. The only way to do that is to cancel out my base. So I'm going to natural log both sides. Natural log and e cancel, leaving me with 4x equals the natural log of 9. And then I just divide by 4. And I get my answer, which should be approximately 0.5493.
Because I have the same thing on my. No, I don't. Wait.
Jim, when I took your.
I didn't divide. I divided, but I didn't. So I took the 3 away. I was like, I didn't write down the answer.
Because I wasn't taking the natural log of the 4, so it can't go inside. So we have to do it in the same order that we were doing it previously. Yeah. Questions, concerns, or issues with that one? Show of hands who got it right or got it to work out. Is anybody confused?
It worked in my brain.
Took your time.
In your brain, but not on paper.
Yeah, because sometimes I write out the work, but I won't write the answers. So then I can't.
If you already wrote the notes, here is example D. You were doing numbers and letters. So this is example D, if you already wrote the notes. So this is 3 times the natural log of 4x equals 24. So this one is the same concept, but it's a little bit different because this time I have a natural log in here instead of an e. but it still kind of works the same way. So the way we're going to do this is we're going to try and isolate the natural log problem here, or natural log term. So the first thing I need to move is the 3. When I do that, I get the natural log of 4x equals 8 because I just divided each side by 3.
Oh, well, this messed my whole problem. Sorry. Didn't you see that?
If you want to change this into a logarithmic equation at this point, you absolutely can, because I know natural log is just log base e. However, I'm going to show you the shortcut. If you don't want to do the shortcut, that's okay. You can always change this into a logarithmic problem. Just use the correct base. So the shortcut on this is I know that the inverse of natural log is what? E. And E is an exponential base. So what I'm going to do is I'm going to raise both sides of my equal sign to a power on a base of E. So this becomes E to the natural log of 4x equals E to the 8. My E and my natural log are going to cancel out, dropping my exponent down, and I get 4x equals E to the 8. I'm just going to give you a second to think through it. It also works out this way if you change it into a logarithmic equation. So if that works more sense, makes more sense to you, you can absolutely do it. You have a natural log or an E button on your calculator, yeah. Yes, ma'am.
So I do the E for the natural log. That's a number. So wait, what is the?
Right, so that's the issue. E times 8 is way different than E to the 8th power. So anytime we use an E, we raise whatever we're taking with it to the power. It has to work that way. Okay? Okay, did we all process this? So the E, we put in there to cancel out our natural log, and whenever we put an E in, we raise everything else to the power on that base E. So these canceled, and that is E to the 8th power. Now to isolate the variable, I just divide by 4, and I get x equals E to the 8th over 4. Let's make sure that we are using the exponential E, so it's usually with E to the x. So you'll press that button, and then instead of an x in the exponent, you'll put an 8. Enter, and then divide by 4. Because if you do 8 divided by 4, it's not going to work. E to the 8, enter, divide by 4.
What if you put E to the 8 in parentheses and then
That should be okay.
like a
745.2395.
It should have the exponent.
Yeah, it should. So, no, you want you're getting natural log. We want thing above natural log, so I'm going to do second natural log every time I use it. Yep. Anybody not get this to work out? Yep. Are we all okay? Please, please, please tell me if you're not getting this. Or if you're not working the calculator right, because that's a huge part of this. We're all okay?
Should we round that many places?
I prefer 4 decimal places, yes. And if you are intending to take dual credit pre-calc next year, it will be 4 decimal places. If you intend to take calculus eventually, it will be 4 decimal places. So that's usually my just bare minimum for an honors class. No, if you put more, it kind of becomes unnecessary after that, but you can definitely put more. That's fine. But at least 4 is what I go for to ensure accuracy. We're going to do one more just as a practice, and then we are completely done.
No, I was fine leaving it where we were. Yeah, me too.
Shane, what do you think we're going to do first?
Oh, I don't. Let me see. Let me look back at it.
Okay.
not sure.
Okay, well, I need to get that natural log term by itself. So right now I have a number in front of it. I need to get rid of that number. So what am I gonna do? Well, I can't make it an exponent because I don't have a log on the other side as well. So I don't really need a log property here. How do I get rid of the 5 though? How do I move it to the other side? I can't minus it because there's no addition happening here, but it's 5 times. So what's the opposite of multiplication? Division. So we're gonna divide that 5 out of both sides. When I do, I get the natural log of 6x equals 8 over 5. If you wanted to turn that into, what, 1.6? I think it's 1.6. Yeah, you can. I don't prefer that though. I prefer you leave as the fraction for now, but I'll take what I can get. Huh?
It's never done that, but now, like, I could put, like.
Are we all okay so far? All I did was divide the 5. Now I have the natural log of 6x equals 8 over 5. Sarah, what am I going to do to get rid of the natural log on the left? Say it. The e, right? I'm going to take e and I'm going to raise it to the power of each of these sides of my equation. So this is going to become e to the natural log of 6x equals e to the 8 divided by 5 power. E and the natural log here cancel, and I get 6x equals e to the 8 over 5. And then to get x by itself, I'll just divide each side by 6. And I can put that into my calculator. And when you do, you should get 0.8255. This is it for the notes. Your homework is on Canvas. It's 5 questions and it is due tomorrow. So feel free to go ahead and start working on that.
You should make this homework worth 50 points.
No, you shouldn't. Then we do bad. Well,